we'll make you the presenter.
Okay. Good morning. My name is Dennis Falloon, and I'm the District 7 Safety Academy Coordinator and District 7 Consultant. And I would welcome you to the 6th District 7 Safety Academy webinar of the 2nd series of safety topics, webinar topics. And today we're going to be covering the crash data collection and analysis of normally known as CDMS. And this will be presented today by Anthony Chamont, P.E. and District 7 Consultant. And before he starts his presentation, I'd just like to give you a brief introduction. Most of you have probably seen this before, but I go through it every time in case there's any changes. Sorry about the feedback, folks. What we have here is a Traffic Safety Academy that's providing information regarding safety-related issues to enhance your local safety programs. And that's the purpose of it. We began this series in March of 2014, and they usually run between 10 a.m. and 12 p.m. The seminars will end for the 2nd series on December 10th, 2014, and they're usually between an hour to 2 hours. Depends on the topic. To register, you go through the SurveyMonkey link here. It's also on your information that you get by email. And as Anthony has already shown you, the Tampa Bay TrafficSafety.com website is where there's a lot of information concerning what's going on with traffic safety, plus the fact that we do post out there the the webinars that are presented. And also the recordings of these webinars. And today, like I showed, this is the calendar. We're on the 30th, the 6th one, Crash Data Collection and Analysis, CDMS, and we have 6 more to go. So looking forward to having you participating. And then for those that are engineers, we have PDHs for Florida's PEs. And this stuff is also out on the web page that Anthony showed you in the very beginning, how to go through this and submit your paperwork for it. You get 1 PDH hour, and it's a separate form for each session. And at this site, this link, you can get the form and submit that to Larry Hagan to process it. Also, we're still working on the AICP hours, and that hopefully will be up in the near future. Also wanted to mention we are still moving forward on the 3rd series of safety topics, and they will begin in January 2015. And anything that comes up regarding that, you'll be given a notice about it. Also, if you have any topic suggestions on anything previously given in the 1st series and the 2nd series you feel we need to elaborate more on, let me know. If you have any new ones, let me know. And that's my email address. And my contact information is this. With that, I'd like to turn it over to Anthony to give his presentation today.
All right, good morning, everyone. I believe I'm showing my screen. So as I was saying during the pregame show there, I'm actually the presenter and the moderator today, so bear with me if there's any questions in the chat that get asked that I don't get to right away. I'm going to do my best to keep up with that, and I guess Dennis will do what he can also to catch those as they come. So today's topic is crash data collection and analysis. Slide. Okay. Quick agenda of the things that I want to talk about. I always like to give you a quick synopsis of what we're about to see. this is going to be a little bit of an unorthodox review of crash data. This isn't exactly going to be a how to use a particular set of tools, because there are several tool suites out there. It's going to be more of an informative, here's some information about crash data, some general knowledge. It's very important to know with crash data how things are located, what some of the intricacies of the actual data fields in there. A quick overview of how the data gets into the database in the first place. So we'll be looking at the HSMV, Department of Highway Safety Motor Vehicles, the crash report form, and the state crash database. A quick look at some of the crash data analysis tools, the state's crash analysis reporting system, the HSMV's FIRES system, and our CDMS system. And warning acronyms ahead. We love our acronyms. This page has 4 of them on it. So just be mindful of that, and we'll look at some examples of how the crash data can be used regardless of the system that you're using for spot reviews, corridor analysis, and systemic studies. So what can the crash data be used for? I mean, this crash data is really a big deal. We do a lot with it in the engineering world. We use it for safety studies, corridor studies, benefit cost calculations, roadway design support, signal warrant studies, funding justification, project prioritization, roadway safety audit of information. Most recently, in District 7, you know what? I'm getting a little bit of feedback there. I'm going to go ahead and mute your microphone. Dennis, I mute keyboard. Dismiss. Okay, Dennis. There you go. That should help a little bit. I believe your speakers were picking up, or your microphone was picking up your speakers. I was saying in District 7, we're in the final stages of the Highway Safety Improvement Program, where all the local agencies submit for projects for that justification of the federal funds. And I mean, crash data is a big component of it. The whole point of the HSIP process is to reduce fatal and severe injury crashes. So it's all about the justification for that, the benefit cost. And if you have any questions on benefit cost and net present value, last semester, I guess semester year, we did a presentation that covered how to do those things. So a quick history of, not a history, but to take you through more or less step by step, because I think it's important to know how, from when a crash occurs at a particular location, how it is that it ends up in a database, how it is that you're able to query that data, what that process looks like. And not everyone knows this. So where does the data come from? So a crash occurs out on the road somewhere. I'm not necessarily implying that the people that get into collisions are dummies, but there's a test dummy. They're getting into a crash. A officer reports, goes and investigates the crash. They do their exchange of information. They fill out the police report form. They do their collision diagram that's part of the form. And the form is really, I mean, that's where all the data comes from. So I want to spend a little bit of time on the Florida crash report form, HSMV 910S. This form was revised in, I believe it was 2011, and there were some pretty sweeping changes in the form itself and the fields, and it made it somewhat challenging to do before and after studies because of how the fields changed. I still find myself using some of the terminology from the old form, and I need to, get used to using the terminology of the new form. But fields like the harmful event, they don't call it angle crashes anymore or rear end crashes. They call them front to side or front to rear. The language of how things are typed in the database changed, and they added a lot of useful fields to the crash report form as well. Like the distracted drivers and cell phone usage, and as time goes on, they make changes to these crash report forms. What it actually looks like is like this. I mean, this is the actual police report that has all the available fields. I know that this is very small to see on your screen, but I've highlighted on the left the main sections. You've got your crash identifiers at the top that just basically it's the location of the crash, and this is very important. We'll spend a little bit of time later on talking about the location because it's the location of the crashes, and having that accurate is kind of key to being able to do any safety study. If you can't query your crashes because you can't identify them, you can't do a safety study. So the police officer here writes the on-street and cross-street. That's what you have to locate the crashes. As more and more agencies do electronic data collection, it's not so much a paper form that's filled out anymore. It's done on the computer. The GPS is tagged as well, which is very, very valuable. It's a QC step for the on-street and cross-street. We always like to QC that lat-long coordinate because, as you know, with mapping information, there are different datums. Some people use the WGS, some people use the state plane, and some of the systems have different lat-longs, and depending on which system you're using, even though you have perfectly located XY data, if you don't know the coordinate system of that data, sometimes it's in degrees, minutes, seconds, sometimes it's in decimal degrees. It can be a mess. I think they probably resolved all of that, but I know that when they first started collecting the data, there was a handful of agencies that we were working with that were collecting the data, and each of their sort of local sheriff's office had a different GPS brand that they were using to physically write the XY data in their crash report forms, and they had different datums, and the data ended up being mostly useless because we were never able to resolve where the crashes were. There's roadway information that tells you about the condition of the roadway. There's the crash information, which is really the meat and potatoes of what we use to identify at a crash level the information that is out there. This is your harmful events, manner of collision, relation to junction, which used to be called site location. It's not called relation to junction. Your contributing causes, your manner of your collision. I mean, this is how we can tell what type of crash it was. Witness information, non-vehicle property damage. On page 2 is vehicle information. The form is split up into, well, I'll talk about that in a minute. It's a relational database where you have multiple vehicles for every event. For every vehicle, you have a driver and multiple passengers along with the injuries. So it's kind of in database speak, what we call a one-to-many relationship because you have one crash, multiple vehicles, multiple people per vehicle. So it's in the background, there's some things that go along with making that efficient and being able to manage that data. And we're pretty good at managing that information. So we have the vehicle information. That's the type of vehicle. Was it a heavy truck? Was it a car? Was it a motorcycle? Motorcycles are important because it's one of the strategic highway safety emphasis areas. They get vulnerable road users. The traffic control device is in here as well. That's useful because we like to identify, signalized intersections that have a certain crash problem, or we like to identify median openings that have a certain problem, and violations. If the person that was involved in the crash for this particular vehicle, if there's any violations that were issued by the reporting officer. And in case you were wondering, that was Rick from The Walking Dead. If anybody happens to watch that show, the picture that I had on the other slide. And then the person information. For every vehicle, there's multiple people. The driver's actions, whether or not the driver was distracted, whether the sun was in his eyes, safety equipment. If it was a motorcycle, lets us know if they were wearing helmets or not. We can run some statistics on injuries for helmets versus non. For vehicles, this is where the seatbelt usage goes, alcohol and drug usage, and passengers, how many people were in the vehicle. Then the narrative, this whole big blank section, it's handwritten sometimes or typed out. This is where the police officer actually describes in prose like what happened in the crash. They say, vehicle 1 was traveling northbound along X road in the outside lane. He was approaching the intersection of its, reads like a story and lets you know really what's happening. And there's a lot of crash types that, this narrative, without the narrative, it would be very difficult to identify exactly what's happening. This is particularly important for bicycle and pedestrian crashes because the crash data fields that are in the database make it challenging to know exactly where the crash occurred. Was the pedestrian 100 feet away from the crosswalk, walking mid-block? Was he going along the median? There's no fields to find those items in the crash report form beyond it was a pedestrian at this intersection. So this narrative really helps out with that. It lets us know also additional passengers, additional violations, and who the reporting officer is. And then, one of my favorite sections of the report is the page that is set aside for the diagram. It's blank, the one there that's on the right. And on the left, I show two samples of, the types of things that are drawn on there. You can sometimes skip almost straight to page 4 of the report and see exactly what happens. That the top picture, it was a pedestrian that was trying to cross from south to north, going at a diagonal. He made it across and was hit in lane number 2 by a through vehicle. The bottom picture is a westbound left turn crash that was hit by an eastbound through. So these pictures are very, very valuable when you're doing a collision diagram or doing a specific study of a location. So all this data gets typed. Used to be that this data was handwritten on the reports. The police is required to send the information to the Department of Highway Safety Motor Vehicles, DHSMV. They're the custodians of the crash data. They used to contract with Pride to digitize the information, but again, more and more the information is being collected electronically, so they're expediting that. And now they have consultants that manage their database for them, the FIRES portal. So the information is sent electronically now for the most part to the HSMV, and they're the ones that own the data, so everything comes from them. The database from that 4-page report is a 314-field database that it's a relational database. If you see the structure down there, that's the actual, it's impossibly small to see, it's tiny, but that's the actual structure of the database, all the tables with the fields, how things relate to each other. You've got your events, you've got your people, you have your injuries, you have, so it's, it's no easy task maintaining a database with the number of records that happen out there on and off system. So the people that do that for HSMV are FIRES. I believe the firm is called APRIS, and FIRES stands for the Florida Integrated Reporting Exchange System. This provides restricted access to the crash data. Law enforcement, government agencies, engineering offices, things, county, city, DOT can get this information. For our CDMS, we have a number of users that purchase the data from FIRES, because that's FIRES' business is HSMV allows them to gather the data and manage the data, and then once it's all set up, then FIRES is able to sell the data. FIRES doesn't get paid directly, I guess, by HSMV. They've got an interesting business model. So the data comes from these guys. The data also can come from the crash analysis reporting system, from the state mainframe, and there are some changes that are coming to this. The state is in the process of upgrading their old mainframe database into a nice online reporting system that's going to be called CAR Online, and this will allow the people within the DOT to query the information by section number of mileposts or intersection names, and get some statistics and get some crash data out of that. There are some other systems, like the one developed by the University of Florida, Signal 4. That's also a web-based system. This began as a partnership with Florida Highway Patrol. They had kind of a backdoor directly into the Florida Highway Patrol data, and they have a pretty neat, actually, query system that allows you to do some quick comparisons from selections, and you can do some things on there. But it's mostly a querying system that allows you to pull the data. I know that they're working on an analytics model for this, so that it'll do some reporting and some more things besides just displaying the data and being able to filter it in different ways. But what they're really good at is just sort of displaying the data and filtering it. Then we have Tyndall Oliver's Crash Data Management System, the CDMS, that began as a partnership with some of the some of the counties and cities and the DOTs. This thing has gone through quite a few different iterations. It used to be a GIS-based system. Then it was a desktop sort of system that integrated the database with Access, and we've moved to a web-based ArcGIS, cloud-based system where the data is stored in a centralized location. Everyone has access to it, and again, it has the querying, filtering, reporting capabilities that you would expect from any of the crash systems. So why do you need a crash data management system? Well, I mean, as you saw, the crash data it's kind of unruly. There's a lot of fields, 314 of them. It's a relational database. If you were just to get a data dump from fires, I mean, you have to be a wizard with the database to be able to do anything with it. So what the systems do is that they provide an interactive suite of tools that allow you to query the data. You can do geographic crash selections, query-based filters, summary graphs, standard reporting. There's some things that are going to be automated. So having a crash data management system of some sort is definitely very, very useful to be able to quickly query information. I always like to point out and remind folks that a crash data management system, I mean, we named ours that because we wanted to never imply that a crash system tells you what the answer is. You always need an engineer to actually read the reports. So to make the decisions and read the reports, I mean, that's kind of the point of it is to start from a very big picture, from a top look of all the crashes, and you're able to very quickly bring the data into GIS, see your hotspots, find out where your problem locations are, zoom into those locations, identify your overrepresentations of crashes. Say there's a particular area that's having a lot of runoff road wet weather crashes. Well, you can filter those out and take them aside, pull the actual police reports up and read them, and then find out what the pattern is, figure out why it is that the crashes are happening. The systems, none of these systems will tell you, this is the countermeasure that you need to implement over here. That they will just tell you these are the crashes that are happening. Which is why I think it's important to know some of the things that I'm talking about here about, how the data is located, where it comes from, and I'm going to get into some of those idiosyncrasies of the data itself, because as you query the systems, no matter what system it is, it's really important to know how it is that the crashes got there. So GIS-based systems allow you to see the crashes on a map. I think that's invaluable. None of us can picture, like the picture that I had of the Matrix with just the numbers going by. That's just not how we see things. We're very visual, so we like seeing the crashes. It's an easy method to provide exports of crash data also to clients and consultants. And if you have accurate crash locations, you can make better decisions in less time. So it's all about being efficient, and it's repeatable, it's consistent. So data-driven analysis, crash selections. What are some of the ways that you can pull crashes if you know the spot that you're going to identify? Well, you can select from street names, drop-down lists. We have on the bottom left, you type in on street, and it identifies all the corresponding cross streets. You can sort them by alphabetical order or geosort them sort of along the corridor, so you can build a corridor of nodes. You can search if you know the actual HSMV number or the intersection node, or you can simply zoom into a map and draw a box around an intersection. But before I get too far down this particular rabbit hole, how are the crashes actually located? I mentioned earlier when we were talking about the police report that they write the on-street and the cross-street, and that most of them now are gathering the XY data. So location, location, location. How do we do it? Successful safety evaluation is highly dependent on the accuracy of the location of the crashes. So let's talk about that for a little bit. There's a few ways that the systems locate the crashes, a couple of conventions. The state uses a linear referencing system, section number of milepost. Every roadway from east to west beginning on the farthest east section at milepost 0, along the corridor, depending on how far it is relative to that base point, has a milepost number, and the street itself has a corresponding section number. Every intersection along the state's linear referencing system also has an intersection node. So you have intersection nodes, which are basically on-street and cross-street, and you have your linear referencing system. There's also the XYs, latitude and longitude, and we've developed something that we call the CDMS intersection node. It's a proprietary node layer, and I'll explain one of the reasons why we did that. So understanding the crash data. Bear with me as I build this picture for you guys. So we have a network of streets here. We have an east-west sort of main line. We have a dogleg intersection over on the west, and we have two normal intersections. Along the corridor, using the state system for the nodes, we would have 4 nodes, 4 intersections, one for every one of the times that the lines cross each other, basically. That's how these layers are built. So these are your intersection nodes. And if you have a simple network like this, then this works really well. You could have some issues at the dogleg there if that's actually the same street. If the north to south street doesn't change names, then when you're querying a system that uses this type of node and you ask it how many crashes are there at this intersection, you will end up with your crashes split at 2 different intersections. So if you're doing a district-wide or a county-wide or whatever distribution of your crashes, and you have a list that aggregates your crashes to the intersection, it can be a little challenging because some of your intersections will have half the number of crashes at them. So that can be a little complicated. Now, the linear referencing system works pretty well for this. Say we have a section number and some mileposts along these. It works pretty well. Every location is identified by 1 section number and 1 milepost, except for that one north-south street that's in the center. If that is also a state road, then the single green node that is in the center there, that's between the 5.84 and the 1.09, can actually be represented by one of 2 combinations of section numbers and mileposts. So when you're doing a spot study, it's important to know there's a convention for which one of the 2 the crashes are associated to. It's important to know to always check for your state-state intersections because you'll end up missing some crashes. So this can get a little bit more complicated with the nodes. Since this is a state-state intersection, if we have a channelized right turn lane, now the intersection of those 2 lines, we have some more nodes. So now we have sort of ramp nodes at those, so the crashes at that intersection are split amongst additional intersections. If our main lines there, the 2 state roads happen to be U.S. highways that are divided and have more channelized right turn lanes, well, now we've got a lot more points on the we have a lot more points on the map. So if we're doing distributions by on-street and cross-street, this can be really challenging to identify the number of crashes, which is why we developed our intersection nodes. We took all the nodes that are associated with a particular location and invented a new node at that and called it the on-street and the cross-street. So all the crashes are aggregated to that intersection node. And the good thing about the system is that we don't get rid of the state intersection nodes or the linear referencing system. You want to give the users a choice. You want to have everybody be able to select, by this system or by that system, by this convention or that, depending on what you're working on. So the linear referencing system is actually really good. It allows you to do some analysis that you can't do with any other system for identifying the crashes. But there are a few limitations that I want to discuss as well, things that you should know about. I already alluded to one of them, and that is the state-state intersection. If you have, the same grid here that we had before, and we have our section numbers and mileposts, sometimes at major intersections, like the east-west corridor here, the state intersections or the section number will change. So that intersection now could be described by up to 4. In this particular instance, the north-south section is continuous, and the east-west splits at that. So when you're querying the crashes at that particular intersection, you may have to do a combination of 3 queries to grab all the crashes that are at that particular location. That's not a huge deal, but all the crashes that are along the green section will be tied to that 10150 section number. All the crashes that are to the east of it will be tied to the 10210 along the blue segment. And if the U.S. highway is the north-south segment, then the crashes along it will be tied to the north-south segment. So just be very mindful of this. I mean, all the crash systems will give you, exactly what it is that you ask. The other thing that is kind of a tricky thing as well is the milepost zero issue that we've identified in a couple of areas, and there's a perfectly good reason for it, and I'm not sure what the best solution for it is. But what happens with milepost zero is that for whatever reason, the algorithm that identifies the mileposts for the crashes, if in the database there is a crash that cannot be located, that has a null value, that is, that there is no value for the milepost. Databases really don't like null values. Queries, it just, there needs to be a value of some sort. So I believe what is happening is that the null values are being converted to 0. And the result of that, for example, along that 10150 between milepost 0 and 1, if there are any crashes along it that have a null value, all of them are being tied to the 0 spot. So you'll have a combination, a bunch of crashes at milepost 0 every time that you do a query from milepost 0 on forward, and those are basically your unlocated crashes. But there's proper crashes that are there, so some of them are false positives, and some of them are actually good crashes. So know that, limitations of the section number of milepost system. So then, is nodes better? Well, I don't know, not really. I mean, we'll explain how that works as well, and it's all about informing the users and the people that are identifying these crashes. So let's build another roadway grid here. So we have a Main Street, that's our east-west corridor. We have Central Avenue, we have First Avenue West, and we have First Street North. All right. Let's concentrate on these 2 intersections. And for the sake of this particular example, let's say we've got a Dunkin' Donuts over there on the southwest section, and we have a Starbucks over on the northeast section. And we're going to tag all the crashes that happen nearest to First Avenue West at Main Street with the same orange color as the intersection. So a crash that occurs here where that other dot appeared, that's pretty easy. No matter where the reporting officer is coming from, they're going to tag this as, it happened a couple hundred feet to the east of First Avenue West along Main Street. That's pretty straightforward. We can all understand and agree that. If a crash happens over by Central Avenue, regardless of where the reporting officer is coming from, the crash there will be tied to Central Avenue at Main Street, a couple hundred feet to the east of it as well. Okay, so far so good. The node system is working and we're happy. So let's add some more crashes here. Let's say that all these crashes here are tied to First at Main. That's where they have the orange number. And they have their corresponding north of the intersection, west of the intersection, a couple hundred feet or whatever. But what happens in that no man's land that's between the 2 nodes? If Dunkin' Donuts is having a sale that day, and the whoever is reporting at the crashes that are happening in that area, they could say these crashes happen a couple thousand feet to the east of First Avenue West along Main Street. And we do the same thing over at Central Avenue. The crashes that are near it happened at the intersection, but if Starbucks is having a sale on their salted caramel latte frappuccinos that are fantastic, If someone's coming from Central Avenue to Main to report on crashes that are happening near that driveway or whatever that is that's in the no man's land, and they could also say, well, these crashes are happening a couple thousand feet to the west of Central Avenue, because there is one field for on-street and cross-street. So this is very important to know. They're tied to a particular node, but geographically, by their XY, by their lat long, they're located far away from the node. So in any of our systems, if we were to draw our box and we were to say, okay, by XY, I want to know all the crashes that happen within this range that I've drawn in the box. So by XY, if you were to do that, at this particular query, you would miss 2 of your crashes along First Avenue West, because there's one to the north and one to the south that are beyond it. You would miss 4 of the crashes that are tagged to that node over to the east, and you would grab 2 crashes that are green. They're actually tied at Central Avenue and Main. If we were to do the same query by node, and we simply said, all right, so I want to know all the crashes that are associated with the node that is within my box, then what you would get is all the orange dots. So you would get these 4 crashes that are very far away from the node, and you would miss the 2 green ones, but you would pick up the additional ones that are to the north and to the south. If we do the same thing over at Central Avenue, if we grab by XY, because this is the selection geographically, because of where your turn lanes are, your medians, this is your study area for your spot. You select your crashes here. If you do it by XY, here you will miss a crash over to the east, over on the right side. You'll grab all your crashes on the north side. You'll miss 2 of them on the south side. And crashes that a police officer wrote, it was at Central Avenue at Main, you're missing those 4 crashes that are in the center, in that no man's land. And you're picking up 2 orange dots within that selection. And again, if you do it by intersection nodes, simply saying by data attributes, I just want all the crashes at Main Street at Central Avenue, then you're going to miss those 2 orange dots and pick up the 4 that are farther away. They're really happening at the median. And what would you do if you actually wanted to study the median itself? There's no intersection node there. That becomes a challenge. You're going to have to draw a big box around the entire thing and say, I want all the crashes that are west of the green node and to the east of the orange node. So it becomes a little bit tricky. I mean, there's limitations to this as well. Another really interesting limitation as well, for example, in Pasco County, you have US 301 and US 98 that intersect to the south of Dade City when they come in, and if it's the same road through that area, and then to the north of Dade City, they split up again. So if a crash comes in to the database and it says, hey, I happened at US 98 and 301 in Pasco County, which intersection is that? Well, there's 2 intersections that could be. One of the ways we resolve this, of course, is with the XY data. These happen to be along the state highway system as well. So we have a section number of mileposts for these. We have a DOT node for them. We have the city. Sometimes we have the address. So locating crashes is no easy task. The other really easy example also is First and Main Street. I mean, how many First and Main Street are there in any given county? Every city has a First and Main or Central Avenue at Main or whatever. So there are limitations to both systems. So what does this all mean? I mean, does it mean that it all is terrible and we should give up? Well, no, absolutely not. We need to understand this, and we need to give informed users choice. Use all the conventions. You're able to search by on-street, cross-street. You're able to search by intersections, search by roadways, your section number of mileposts, and you're able to define geographic areas. And you can build these queries additive on top of each other to say, I want the crashes that are within this geographic area and the ones that are tied with the node and the ones that also match the section number of mileposts. Depending on what it is that you're working on, it may be appropriate to do that. And that's a long-winded discussion on locating of crashes and how it is that it's done and how some of the systems will identify crashes, but it's imperative If you ever receive or you generate a list of intersections that say, here's a node number and an intersection name, number of crashes, you've got your top 50 angle and left turn nodes in your city. What does that mean? How were these crashes pooled? How were they aggregated to that node? Was it by XY? Was it by the node? It's just, you need to understand what the data is and what it is trying to tell you. On to something a little bit more fun, I think, with understanding the crash data. Angle versus left turn crash. This is one of my pet peeves. We end up saying angle and left turn crashes with a lot of locations because it's really challenging. So is this an angle or is this a left turn crash? I mean, I've obviously blocked out a big section of this, and I wish I had set up a poll. I would have loved to have gotten some feedback here from the audience. I think everyone can agree that this particular picture, how it is set up right now, it is an angle crash. It's a southbound vehicle striking a westbound vehicle, or a westbound striking a southbound. Who's at fault here isn't the point. But if we remove the gray area and I show you the rest of the picture and we zoom out, because remember, a crash report, when you're reading a crash report, it is a snapshot. It's a snapshot of the position of the vehicle movements, of the directions at the time of the crash. The narrative will sometimes tell you, well, it usually tells you this crash was traveling along, this vehicle was traveling along this road, he came out of this driveway, he was coming over, he didn't see it. So you need to read those narratives to understand. But if I remove that gray area, that crash that we believed to be an angle crash, if you were to zoom out a little bit, well, you would actually see that it's a left-turning vehicle that hit a southbound vehicle. So this is a left-turn crash. But is it a westbound left turn or is it a northbound left turn? That's another sort of point of contention with these angle and left turn crashes. The convention here is to refer to the left turning crash as the road that they came from, not the road that they're going into. Most people would call this a northbound left turn crash. There's a handful of folks that, because the northbound left turn driver was intending to head to the west, then he is westbound. But the convention generally is that this is a northbound left turn crash. So let's do another one. This is a side swipe, both southbound vehicles. Well, let's see. If we eliminate the gray area, well, it's a left turn crash, but he's coming from the west. So it's actually an angle crash, even though he's making a left turn movement. The difference between angle and left turn crashes, the way that I like to picture them, is by how they would be mitigated. If there are no traffic control devices out there, say that's a four-way stop, this crash could be corrected by installing a traffic signal, because one of the two vehicles would have the green and the other one would have a red. So that's an angle crash. That's a really easy way of thinking about them. The previous picture, if I go back to that real quick, a traffic signal that has permissive phases, only green balls, would not correct this crash. They both have green. Only a protective phase with a green arrow or a red arrow would correct this crash. So it's a left turning crash. That's a really easy way of remembering left versus angle crash. Let's do one more here. Where are we at? Whoop, next slide. Let's do one more. So angle crash, eastbound, southbound, you know the drill. Let's get rid of the gray. Oh boy. So we have a westbound left turn that is striking a southbound left turn. So is it a left turning crash? Well, if we had a left turn arrow, it wouldn't have done anything. What happened here actually is that someone ran the light. So just having a traffic signal would have prevented this if this was, for example, at a four-way stop or a two-way stop. So this is actually an angle crash. It just so happens that the vehicle movements are both left turns. So now that we know some of that information, data-driven analysis, what are some things that can be done with the data? I mean, any of the systems, these are just screen caps of the crash data management system and some of the exports that it does, but I mean, any one of the systems will do this. Quick links to police reports. Being able to read the narrative is imperative. Again, anytime that you're doing a study somewhere, don't make an engineering decision, on a construction project that's $1 million without reading every police report and making sure that particularly for benefit cost calculations, that the improvement, matches the crashes that are happening out there. So, the system will take any selection and it'll batch export a view of the crashes. You've got the case IDs, which are the police report numbers, and there's a hyperlink to the corresponding scanned police report that allows you to read them. Data summary reports, by just selecting an intersection and saying, give me all the crashes. There's a battery of reports that'll give you trends and harmful events and distributions and time of day, and it's like a 13-page report that comes out of the system. That's a standard report. Crash diagrams. This is a really cool tool. These are some of the symbols. They're a little small, but you see, the angle versus left turn issues that we were just talking about. For example, the orange Ford over there that's next to the pedestrian, that's a left turn crash. The other ones are angle crashes, even though you happen to be making a left turn. The collision diagrams that we generate are a little unique also because they're intersection-based, but at intersections, if you recall from the previous illustrations, when we have those crashes, they can be thousands of feet away from an intersection. So the crashes that are within the box of the intersection, sort of away from where the approaches are all the crashes that are associated with that are at intersection. That's their relation to junction, and the driveway related, the away from intersection, or the I guess related to intersection is the other relation junction, or the ones that are on the approaches. So sometimes you can see like that eastbound approach has red for the rear ends. So there's some queuing issue over there. There's a driveway. There's something where there's the crashes are happening away from the intersection. They're not exactly at the intersection. This is the north-south corridor. You see the pink is the heaviest, the rear ends there. But these crash diagrams are very useful. You can click on any one of those pictures also and bring up a list of the actual reports, and you can read them. And if something is diagrammed incorrectly, then you're able to type them to any of the images. So it's pretty useful. There's a question mark down on the bottom right. Everyone always asks, what is that? The systems, any system that does automated crash diagrams is not able to identify 100% of the crashes. There's oftentimes, just because of a mistake in the coding of the data or in the filling out of the police report, you'll see things like northbound through vehicle collides with northbound through vehicle, harmful event angle. Sure, the angle is 0 degrees between the rear end collisions, but the harmful event there really should have been rear end or front to rear, should not have been angle. So when the data points to an impossible combination of contributing cause, harmful event, vehicle movement, direction from intersection, it goes into a question mark, and then a user, you, the person doing the analysis, reads those reports and types them and puts them in the right spot. And you've got thematic layers also in GIS. There's a lot of really cool things you can do with the data. Make different colored pie charts and different size dots and things to represent the data in any way that you want. You can do your distributions and your graphs, graphical trends. Pictures worth 1,000 words, and we like our graphical trends. So some of the things that we like to do with our spot and segment analysis is take those collision diagrams. If we were doing a corridor, for example, I guess from left to right, from right to left, you have an overview that shows, plots along the corridor. And then the center picture shows you what one of those looks like. And we've taken the collision diagram images that someone has painstakingly coded correctly and read all the reports and identified them. And by their location, distance away from the intersection, this happens to be along the state highway system, so it was a lot easier because it's done by section number milepost. The crash diagrams can be illustrated along a corridor. This is really cool if you're doing a roadway safety audit, walking down a corridor and seeing, well, at this particular location we had this, angle crashes, fixed objects, we had, right turning crashes, we had side swipes. We call these collision diagram map plots. They're really cool to take those automated images and putting them along a corridor on an aerial. Something that's a little bit less automated, but perhaps more accurate. Everybody does these, is taking the crashes and just drawing them in CAD and doing them along the corridor as well. It's a little bit more labor intensive, but when you're doing a bicycle and pedestrian study, particularly along a corridor, you really need to have all the information be accurate so someone reads every report and plots them along an aerial. The direction of the pedestrians walking is actually illustrated on here. This particular map also has the usage, like you see restaurant, gas station. We've got the locations of the light luminaires, and we have the locations of the bus stops along with their alighting and boarding data. So it's really a transit pedestrian study. This is really cool. Just things that you can do with the data. It's not exactly just an output from the system. You don't push a button to generate these. But once you identify this is a pedestrian high crash location, then you're able to zoom into that area, query all your crashes, filter by biped, do an export of your crash data with the corresponding scan report images, read them, and you can have a CAD technician generate this figure. So those are some of the things that that are done with the crash data for segment analysis. There's another the crash type matrix for systemic studies. This is it's kind of difficult to explain all the information that is on there, and I know this is impossibly small to see, but what this does is that it takes every intersection in a jurisdiction, every node basically, and whatever corresponding information we happen to have. This is on system, so there's a roadway ID, there's an on-street and cross-street, there's node descriptions, you have VMT, you have crash rates, and what this particular matrix does is that as a Boolean, it identifies every crash based on all the crash data attributes, the 314 attributes that are in the table, and it determines yes or no for every crash whether or not it meets a particular criteria. For example, the strategic highway safety emphasis areas, aggressive driving at an intersection, lane departure, and vulnerable road users. Does it meet the criteria, yes, no, and then sum them. So it tells you the number of crashes at that node, total, the number of fatalities at that node, the number of crashes that are aggressive driving, the number of crashes that are at an intersection, the number of crashes that are vulnerable road users. And then we develop these what we call countermeasures, but it's not telling you to go do this. It's just telling you that these crashes meet the criteria. For example, signalized stop control location would identify crashes regardless of the node. What it does is that it says, well, is the traffic control device not equal to traffic signal, and is it an angle or left turn crash? Because those are the types of crashes that you can typically mitigate with signalizing a stop control location. Closed median. Well, is it away from a signalized intersection? So we don't care about signals anymore. We're obviously not going to close a signalized intersection. Is it a driveway related or median related? What lane is it in? Angle and left turn crash. Protected left turns. Well, is that a signal and it's in a left turn crash? Backplates. Is it an east-west rear end collision that happened at a signal along an east-west corridor? Access management review. Are they driveway related? So this is a quick little thing that allows you to sort by any criteria and then look at your top locations and also cross-check along it to see what else may be happening at that particular location. Like that top location, for example, you can't really see what the numbers are, but it has red for lane departure. It also has red for heavy trucks. So you've got possibly heavy trucks that are running off the road, and it's in the high percentile for fatal crashes, and also closed medians. So the top location for one criteria, while you're out there doing a safety study, a tool like this would allow you to also find perhaps other things that you could consider when you're out there. So these crash matrices are really neat. I mentioned earlier also that the state highway system's linear referencing system lets you do things that other systems cannot, and this is an example of that. The routed rolling segmented crash maps. What this does along the state highway system is that it groups the crashes along, I believe these are quarter-mile segments, as my legends say. I believe these are quarter-mile segments, and it sums the number of crashes along the segments. This happens to be percentage of nighttime crashes. So the highest number, so it's the total number of crashes within each of those, from milepost 0 to milepost 0.25, from milepost 0.25 to milepost 5, from milepost 5 to milepost 0.75, all down the entire section. It is the number of nighttime crashes within each of those segments divided by the total number of crashes within each of those segments. So it gives you a percentage of nighttime crashes. 25 to 30% is about the state average. This cutoff here is 25%. So anything orange or above are locations that have overrepresentation of crashes. And then it's very small to see on there, but there's little numbers that are above each of the segments to let you know the number of nighttime crashes. Because if you have one nighttime crash, but there's only one crash within the segment because you're out in the middle of nowhere, it's going to be 100%. So you may not necessarily have a nighttime crash issue there. So you need to standardize your data. It's not just divide one from the other and mindlessly let the system do math for you. You want to think about what you're doing. For systemic studies, intersection summary maps, these are really cool also. Basically, what this does is just total number of crashes that are aggregated to the nodes, whether this is a proprietary node layer or the one that the state has developed and provided. So the larger red dots are more crashes, and the smaller green dots are less crashes. This map happens to be bike ped crashes in Hillsborough County. So you can see, from a big picture, top-down approach, what it is that is happening, and what areas to concentrate. These systemic studies, we have a top-down and a bottom-up approach to the crash data. The top-down is looking at the big picture and identifying the trends, and the bottom-up is, for example, addressing your 5% report. So these are locations that we know have issues. Someone else has identified them, or it's a hotspot location because there's been a whole high-profile fatal crash or whatever the case may be. If you know what location you're going to study, then you go straight to that location, you query your crashes, and you do your evaluation. But what often happens when we're doing that is that during that study, we identify unique geometric conditions or something unique in the crash pattern, and that begs the question, wow, if that is happening at this intersection, I wonder if it's happening at another intersection. So then after completing that study, then we look at a top-down approach and find the rest of the locations in the jurisdiction that meet that criteria. So you're being proactive, you're attacking it from both sides, you're being responsive, but you're also being proactive. It's the best way of doing the sort of a safety program. For different types of crashes as well, instead of aggregating all your crashes to a node, we do these bubble maps. What this does is that it puts a point along the roadway wherever there is a crash, and then we buffer those crashes by a certain distance, and it varies depending on the type of crash and the area that we're in, depending on how dense it is. And then where those buffers overlap, they're combined into one kind of bubble blob. The number of crashes underneath the blob are counted, and that is what is represented here. So it gives you a density of the number of crashes. You can have a smaller red dot that has a lot of crashes concentrated on it, or you can have a larger area. So this gives you a view of the crashes for an entire system that is not necessarily dependent on well, along what section number is it? Along what state route number is it? Or along what road? This is just an area-wide, almost like a heat map. You see those crime statistical maps of the area, so it gives you, you can get a larger buffer area. So these are really useful. Other things is the integration of crash data with lighting level data. Don't limit yourself when you're doing your studies to looking at just the crashes. This is a study that identified corridors that had an overrepresentation of nighttime crashes, and the Center for Urban Transportation, Cutter over at USF, has a tool where they drive a vehicle up and down the road and collect foot candle readings. They collect the lighting level data every 10 feet. So what you see in the upper left-hand corner here is a condition diagram of the lighting. You see on the upper right the actual light levels, and on the bottom left is the crash data. So you have total number of crashes, nighttime, your percentage, it's 33, so it's above your state average. Pedestrian number of crashes, 66% of them are at night. Bicycle crashes, 33% of them are at night. So data-driven analysis, identify the locations, look at it, be systemic about it, and prioritize your locations. And the next thing that we're working on is tracking all this, keeping a history of your studies. Track your actions. So within the same system, someone can create a geographic boundary around a particular study area, and based off the findings, for example, you can do a roadway safety audit. This is an RSA tracker. You can add points on a map and track your actionable recommendations. Have some accountability for those items, and you can also preserve your institutional knowledge as people come and go if you have a system that tracks all your studies. So it's all integrated. This is in the same system as the crashes. So down the road, you'll be able to do before and after studies by selecting that study boundary and saying, hey, give me all the crashes that happened 3 years ago, give me all the crashes that happened 6 years ago, and you can do it before and after and make sure that everything is working. So integrating different layers together is pretty useful. So quick little recap here. We're finish line, almost there. The crash data, it's used for justifying safety funds, safety grants, proactively identifying safety studies, safety locations, supporting law enforcement, supporting data requests, strategic priorities, trend analysis. It's all about being able to make better decisions. Know your crash data. Know your crash data management system, whichever one it is that you're using. Crash data queries are an art and a science. You saw in those little illustrations that I was drawing how if you select by X, Y, or by node, you'll get different numbers. That's frustrating to some people, but if you understand what it is that you're asking the system, then you'll understand what it is that it's giving you, and you'll make a much better safety study. There's no cookie-cutter solution. It requires creativity, requires judgment, and FDOT and their consultants, and I mean there's a lot of safety experts out there that are always available if anybody has any technical questions. With that, I will open this to questions. Let me open up the chat window and see if there's anything that has been asked in here. All right, looks like we have some. Great. Let's see. Feedback has ended. Good. When did the crash report form change? I believe it was 2011. I can verify that, but I think the crash report form changed in 2011. There's a question about police departments, and well, we're getting the feedback again. Is that you, Dennis? Yeah, it's me, you again. If police departments are invited to these webinars, and I mean there's a plethora of people that are invited to these webinars. We have hundreds of people that sign up, and I don't know, there's 56 people that are on right now. And yeah, I mean through our CTST, we talk to the officers. They know how important this is. The crash data is not used just for insurance purposes, which is kind of what the cynical person, the uninformed person of the millions of dollars of decisions that are made with crash data would say is that, the only reason to do this is for insurance purposes. But yeah, I mean, I believe that the police officers are aware of how important this is. Is there standardized training for police officers on how to fill out the forms so that crashes are identified consistently? It doesn't seem to be so based on what I've seen. I agree. But yeah, there's a handbook, on how to fill out the form, and they do training. It just, I don't know. I don't know what to tell you as far as why it doesn't seem like it's consistent. I don't know if I can open this up to the guys over at DOT and to the other consultants that are on the line to see if anybody has any anything else to add to those particular. Let me unmute. Let me unmute the district guys. Where are they at? Robert, Nina. At least Larry. Larry's probably. Hey, Larry. I unmuted you if you want to chime in during any of the Q&A here. And the short form, to my knowledge, the short form has been eliminated, although I'm still seeing some out there. What was supposed to be done in 2011 when they consolidated they were supposed to consolidate both forms, basically. And if it is intended to be a short form, there are only some fields that are filled out and others are left blank. It's the shaded fields in the crash report form that are the ones that are required for the short forms, and the other ones are for the long forms. I think there's been some changes to that, but it was supposed to be eliminated, which was an issue prior to 2011. There was a handful of agencies that relied on the state on the crash on cars, on the crash analysis reporting system for their crash data, and historically the state has not included short forms in their database. The short form are mostly are fender benders, and they weren't in the crash database. Only the injury crashes and the long form crashes were the ones that were in the state database. So the local agencies have to rely on PRIDE before and now fires to get the data if they want their short forms. But I believe with it being consolidated, the state is actually obtaining all the data now if anybody is relying on cars for their crash data. But for the scan report images, the state does not release those. So that's why a lot of people are still using fires to get their scan report images, so that you can quickly click on a button and grab those scan reports. There's a question here. Are you telling us there is no way to export crash points as XY coordinates? All the points are located only at intersections, and I should read the specific crash report form in order to move the point from the intersection to its proper location. No, the crashes are depending on the system that you're using. I can speak to the CDMS. In the CDMS, the crashes can be queried by node number, and they can also be queried geographically by their XY. There's actually an export button that will take whatever selection you have and export it out to Google Earth as a KML or as a shapefile, and the location of the point when it is exported is the XY of the point. So yeah, absolutely, you can export the crash points as XY coordinates, but there are some crashes that don't have an XY for whatever reason. They weren't located. You have that first and main issue, or that US 98 at US 301 issue, and the crashes will be aggregated to the node. The state provides XY coordinates for all of their crashes on and off system on an annual basis. So we go in after the fact and clean up any of the locating that it was missing the XYs that were associated with the XY of the node on an annual basis when the data is released. Because we work with traffic ops a lot, and the name of the game is do something now. We're interested in the most recent unofficial data when we're out there, because we don't want to wait 2 years down the road before we get the data to say, oh, there's been people that are dying out here, every other day. So we have in-house staff that looks at those crashes that were not able to be identified by the system, right? Like if we get a dump from fires and import it into the system, we're able to locate with a pretty high confidence level, probably 80% of the crashes. Just automatically, boom, they're located, they're in the right spot. And the rest of them it's misspelled so badly in the police form, or it's the intersection of two parallel streets that don't intersect, things of that nature, that someone reads the reports in the office here and locates the crashes. We have a heads-up display that brings up the police report and the on-street, cross-street. They can read the narrative. They can, find. Sometimes it just says Walmart driveway. What is that? That's not an intersection. So it needs to be identified, and those crashes are located. And we get it up to, I think, 95% of the crashes located. There'll always be some crashes that can't be located. And then on an annual basis, the state comes along and says, hey, here's the XY for all the crashes, and we go back and correct some of those. Additionally, the system that we have for locating those crashes learns aliases. If there's a particular cross street that on the north side of the road is named one thing and on the east side of the road is named something else, and our node layer didn't have that in it, and a human in the office keeps locating crashes to the same street doesn't exist in the non-unique table, the system realizes that and says, hey, you've tagged this crash with this alias to this location enough times that I think we ought to create a node or create an alias. So then it learns that particular alias, and the next time that a crash comes in with that particular cross street, it gets automatically located to that location. So it learns and it becomes more efficient. Can we obtain a certificate of attendance for this webinar? Thanks. Sure. We can get something for you. If you can send me an email if you require a certificate of attendance, and we can get something for you. I can jot down your name so I can get something to you.
Hey, Anthony?
Yes.
This is Dennis. Let's get an email from Christopher, like you were saying, but I'm checking into the certificates with somebody at DOT, so let me work with you on that one.
Okay.
Okay.
Sure. Maybe I said it, but I missed it. What is the name of the software you use to display the crash diagram? That is the Crash Data Management System, CDMS. It's a proprietary system developed by my firm, to analyze the data. All the screen caps basically were of my system, but the the fire system, or not the fires, the Signal 4 system also does similar things. There's an old one that does crash diagrams by Intersection Magic, and I'm not sure if the online car system is going to do things like that, but the one that I was talking about was the CDMS, Crash Data Management System. Are there training sessions scheduled on using the new CDMS interface? Robert, yeah, we can work with you, Robert, to train on using the new CDMS. I know that Juan has the the beta tools out there, and I guess that's what you're referring to. But we can certainly work with you and do that independently. Not a big open webinar, but we'll go to your office and train you on how to do things with the new CDMS. Let's see. If 3 off-road crashes happen within an intersection, does this mean that the speed is fast if the roadway has a slow curve near the intersection and the speed limit is 45 miles an hour? Well, okay, if you're referring to the crash diagrams and how it said the run-off road crashes are within the intersection, that's a bit of a misnomer. I didn't mention that when I was talking about it, but I can illustrate it real quick. That crash diagram tool is right here. We have runoff road, hit fixed object, pedestrians, and bicycles would be here, right in the center of the intersection. This is one of those, and I illustrated that earlier when I was talking about the necessity of reading the police reports. The crash data just doesn't have enough fields, and I think it will be too cumbersome to fill out to know, okay, it was a southbound pedestrian that was 100 feet east of the intersection that was walking along the median, and he was hit on the inside. It just doesn't, there's not enough information in the data for a system to automatically tag it and put, well, the crash actually happened right here, or the pedestrian crash actually, so what we've done instead is put them in the center of the intersection, and we say, hey, there's 3 pedestrian crashes somewhere in the influence of this entire intersection. Same with runoff road. There are 2 runoff road crashes somewhere in the influence of this intersection. Fixed objects, same thing. Bikes, same thing. But to your question, though, if there's an intersection with a lot of runoff road crashes, I mean, sure, if it's along a curve, it can mean that there's a speeding issue. I mean, if the crashes are happening at night, it could be that the curve isn't signed properly. If they're happening in the rain, it could be that there's friction issues on the roadway. It may need to be resurfaced. So it's a number of it could be a number of things. Does your firm grant access to the CDMS? Bit of a loaded question. It's an in-house tool that we allow the county, city, and DOT agencies that we do work for use. So it's not a tool, and I guess they're consultants as well. So we don't sell it as a piece of software for other consultants or other agencies to use. But if we're on contract with you and we're doing your safety studies for you, then the CDMS is it's how we do our studies, and because it's how we do them, then we allow you access to it as well. That way you see what we're doing and able to access the information and field some smaller requests that don't require a call to us. Can we have a copy of this presentation? Yes, absolutely. The presentation will be posted on the Tampa Bay Traffic Safety website, the Safety Academy tab. Sandra asked, who asked the question? Who asked the question about the training? That was Hillsborough County asked the question about the training. So I mean, yeah, we can work with one. I mean, we have there's a training manual, there's videos, and as tools change, we work with all of our users and do kind of one-on-one training with their power users and show them some of the new functionality. One of the neat things about how it's set up is if there's new functionality, if there's a new tool that someone needs, like the project tracking, roadway safety audit little module that we're beginning to develop. That's something that eventually will be trickled down to the rest of the users. So, Sandra or Robert, if that's something that you guys are interested in, definitely contact them or Juan, just so that we can work on that and customize it and work with you guys to implement that so that you can track your studies along with your crashes. Any other questions? So the chat has died down a little bit. Go back here to the end. I want to remind everyone of some info at the end. Again, today was the July 30th presentation, crash data collection analysis using the CDMS. August 20th is our next webinar. That will be on signing and pavement marking retroreflectivity. That is August 30th. Again, for PDH credits, they can be downloaded from the Tampa Bay Traffic Safety site. If you scroll all the way down on the Safety Academy page, I can show you, I think. Yep, right on the Tampa Bay Traffic Safety site here. If you scroll all the way down to the bottom, there's a resource tab, and there's the PDH request form here. So download this to your desktop, fill it out, and email it to that address, to Larry Hagan, and you will get your PDH. And this is where the webinar will be, the presentation and the recording will be posted. Again, there's the website. It's where it's going to be posted. And as Dennis indicated, we're working on the AFTP credits. And if anybody has any questions, follow-up items, anything that wasn't discussed during the Q&A, my name's Anthony Chamont, and Dennis Falloon can also help out. Go back to the chat. All right, it doesn't look like we have any other questions, so I'll go ahead and stop the recording now. We'll stay on the line if anybody, has anything else that they want.